Hello, today we're going to review what we've learned on polynomials. We're going to talk about adding and subtracting like terms. But before we can add and subtract like terms, what are like terms? Let's write a list of some terms. 3x minus 4x, 2x, 1/2 x. Are these like terms? Well, the numbers are different. But what do they have in common? They all have the variable x. Well, what about this one, 3x squared? Is this a like term with these ones here? Well, it's got a number. These all had different numbers. That didn't matter. They all have x, but this one has an x squared. When you say x and you say x squared, it sounds different because they're different. They're not the same. They're not like terms, and I like to say that they're from a different family. This would be the x family. This is the 3x squared, the x squared family. We can have 4x squared, we can have 5x squared, we can have negative 1/3 x squared, and because they all have an x squared, they would be considered the x squared family. So, how do we know if it's from the same family? Same variable with the same exponent. Well, do you have to have one variable, two variables? How does it work? What if I put xy, 3xy, negative 4yx? Are these from the same family? Well, they all have an x, they all have a y, but somehow this one's in a different order. Does it matter? Does the order matter? Well, let's see. What does it mean when you have two variables attached like this? Well, it means that we are multiplying x times y. Is it the same? Is it equal to y times x? If I put in a number, I'll put a 1 for x, I'll put a 2 for y. I'll do the same on this side. We're going to put a 1 and we're going to put a 2. Are they the same? 1 times 2 is 2. 2 times 1 is 2. Yes, they are. So in order to figure out whether you have like terms or common families, what you have to do is see that you have the same variable with the same exponent. It doesn't matter the order. Let's try one other one and see if you can see the difference between these ones. What if we put xy squared, x squared y, x squared y squared? Are these from the same families? Well, this is the xy squared family, this is the x squared y family, this is the x squared y squared family. They don't sound the same. The exponent here is a 1, and here it's a 2. Here the x has a 2, and this one has a 1. And here they both have exponent 2. So no, these ones are not from the same family. The exponents are different. Yes, this is an x, this is a y, but the exponents don't match up. So now that we know what are like terms and what families look like, how are we going to add and subtract them? Well, let's try this. I like to think that all of these terms, or these families, are going to a party. And here we have okay, so we've got the x squared family attending, and we have y squared family attending. Well, how many of these families? In order to add and subtract like terms, you want to put them together. So what I'd like to do is I'm going to circle these, and I'm going to also circle the sign, because that is very, very important. This is a different family, so I'm going to use a block so that I know that these are different. And I'm going to keep the sign so I know what they are. I'm not going to worry about subtracting, because when I add negatives, it's as though it's a subtraction. And why do that when you can just add? So if I take 3x squared plus 4x squared, I have 7x squared. Minus 3y squared and minus 2y squared is minus 5y squared. Can I add these two together? Can I further simplify? Well, I've got 7x squared who remained at the party and 5 of them left and were never there. And no, I cannot simplify because these are not the same. And we are done. Now, what if we had brackets? What happens here? Well, this is a grouping. This is a grouping. This one's a subtraction here on its own. What can we do? We want them all together, so we want to get rid of these brackets. But there's a problem because in front of these brackets, this one here has a negative. Is it just a floating negative? What does it mean? It's actually a -1. And this is very important to remember because this is going to affect every one of these terms inside the bracket. Before I move on, I would like to talk to you about distributive property because this here is a multiplication. We have a -1 and then a bracket, which means we are multiplying. And so let's look at multiplying before we can simplify this. What does this mean? This is called the distributive property. Or we're going to use a distributive property to do this. So, it says we have 3 of these. So if I were to rewrite this, I can say 2x minus 4y. There's 3 of them. So plus 2x minus 4y. Oh, and I still have another one. So these minus. Always be careful with your signs. So we now have 3 of these. Okay, and they're all additions. And so what we can do here is remove the brackets because it doesn't make a difference because in front of these is a +1. And whenever you have a +1 multiplied by anything, it remains the same. Is there an easier way to do this? If I had 10 bracket 2x minus 4y, am I going to rewrite this 10 times and run out of space on my page? It would take a long time. Is there an easier way to do this? Well, what if we multiplied it out? If we added these ones here, we would find out that 2x minus 4y plus another 2x minus 4y plus another 2x minus 4y. We could add them. Again, we can look at these as different families at a party. We've got the 2x and the plus 2x and a plus 2x, which gives me 6x. I've got a minus 4y, another minus 4y, and another minus 4y, and that will give me minus 12y. If I look at this answer and I look at what we started off with, is there a way to simplify? If you thought that you can multiply 3 by 2x and 3 by -4y and got this, you would be correct. And that's what's called the distributive property. When there is a number on the outside of a bracket, it's being multiplied by every number on the inside of the bracket. So let me show you how I would do this. Now I like to tell a story. I like stories and I like numbers and I like relationships. And so here's my little story that I tell my grade 9s. I say that in order, this is like a little apartment. We have a nice little couple here. And this one is visiting. In order to visit, when you visit someone, you shake hands. You shake hands with everyone, otherwise it's rude. And so here's my multiplication. Every shake of a hand is a multiplication. 3 times 2x, 6x. 3 times, don't forget your negative, -4y is -12y. And so this is how you use the distributive property, multiplying the outside term with every term on the inside. So let's go back to that question where we were adding and subtracting and we had some negatives. Let's look at that one more time. going to write a new question because I've already forgotten what the other one was. But here we go. Let's start with this one. The number in front of here, I don't see one. But because there is one grouping, there is one of these. There's also one grouping of here, but there's a negative. And just remember that this negative is really a -1 in front of the bracket. We don't put it there, but you need to remember that. And if I use my distributive property, which in this case doesn't change a thing, but what happens here? It will change the sign. -1 times 4x, -4x, -1 times 2x, -2y. Now, can I simplify? Do I have members of the same family? Yes, I do. Here's my 2x, here's my -4x, that gives me -2x. What about the y family? Here they are, +3, -2, and that gives us -1y. I don't have to write the 1, but I know there's a 1y. And there you have it. It's simplified, and that's all you have to do. So the thing to remember is that whenever you have a negative in front of a bracket, all the signs are going to change with each term inside the bracket because it's as though you're multiplying a -1 to everything inside the bracket. And then you can collect your like terms and solve your answer. Is that it? Can I stop?